Welcome to G World Education. In my previous section, I have discussed direction cosines of a line. Here, I am discussing about direction ratios of a line. So, let LMN your direction cosines. LMN is d.cs of a line L. And suppose a set of points and a set of points A, B, C are said to be my DRS of line L if it satisfies the following condition. If it satisfies this proportion A by L equal to B by M equal to C by N. If these proportions are satisfied by these real numbers A, B, C, then A, B, C are called my direction ratios of that line L. And what is your LMN? LMN are your direction cosines, and all LMN all are non-zero. Okay. So this is my direction ratios. And since direction ratios are the proportions to this LMN, so there are number of proportionality. So you can say that direction ratios and direction ratios are denoted by this small ABC. Direction cosines are denoted by this, but direction ratios are denoted in this way. Okay, and you know that direction cosines are always unique, but since direction ratios are the proportionality to your direction cosines, so there may be number of proportions. So we can say that direction ratios need not be unique, but direction cosines is always unique, but direction ratios need not be unique. There may be infinite number of direction ratios. Okay, then another important fact, how to find direction cosines from direction ratios. How to find direction cosines from direction ratios. Let's see. So from this relation, what is my direction ratios? Direction ratios satisfies this condition, A by L equal to B by M equal to C by N, and no problem to write this proportion equal to this much. No problem to write this. You can take square root of both. You can take this much. Okay, no problem. And since we know that these are LMN are my direction cosines, and we know direction cosines satisfies this property. So I just apply this property here. Then this will becomes, write it in a individual way. This will becomes this much. Since this is 1, so what is your L? So my L is A divided by this much. This is my L. And what is my M? So just comparing these two proportions. Okay. Then what is my M? My M becomes B divided by a square plus b square plus c square, this much. And my similar way, my n is c divided by a square plus b square plus c square. Okay, so this is the formula to find direction cosines from a given set of direction ratios. I mean, if direction ratios are given to you, I mean if a, b, c are given to you, you have to find L, M, N, I mean direction cosines of that line. By using these formulas, you can find direction cosines from direction ratios. Okay, and a very important note for you. Important note: direction cosines can be considered as direction ratios. You can consider your direction cosines are your direction ratios, but not in a converse way. I mean direction ratios need not be considered as your direction cosines. See, listen it very carefully. Direction cosines can be considered as your direction ratios, but direction ratios need not be considered as your direction cosines. So the question arises, in which condition direction cosines can be considered as your in which condition direction ratios can be considered as your direction cosines. So in which condition? Suppose ABC, this is your direction ratios, and ABC are the direction ratios of a line L if this satisfies the condition, if here ABC are your direction ratios of a line and these are called your direction cosines if and only if it satisfies this condition. If and only if a square plus b square plus c square equal to 1. I mean, if direction ratios satisfies this condition, direction ratios ABC satisfies this condition, I mean a square plus b square plus c square equal to 1, then we can say that this as your direction cosines. So under this condition, a direction ratios can be considered as your direction cosines, but direction cosines always considered as your direction ratios. This is the difference between direction ratios and direction cosines. And then another important formula for direction ratios: suppose a set of points are given to you. Let x1, y1 and z1, x1, y1, z1, x2, y2, z2. 2 points are given to you. 2 points x1, y1, z1 and x2, y2, z2 are given to you. You have to find direction cosine of a line joining these 2 points. Suppose P and Q are 2 points having coordinate x1, y1, z1 and x2, y2, z2. So how to find the direction ratios of the line joining these 2 points? I mean direction ratios of PQ. So how to find this? Just use a simple formula. This is x2 minus x1 and y2 minus y1 z2 minus z1. Just using this simple formula, you can find direction ratios of a line PQ having coordinate x1, y1, z1 and x2, y2, z2. And if you once you get direction ratios, from direction ratios you can easily find the direction cosines of that line. Okay, so this is all about your direction ratios and direction cosines, and in my coming section I will go with problems on this section. Okay, thank you for your watching.